Season 1, Episode 1, Vintage Electronics. I'm Ray Potter.
And I'm
This is
John
John DeMeo. And we're here in John's house with his Museum of Yesterday. As you can see, lots of neat old stuff.
Museum of Yesterday encompasses the American idea of industrial development from about 1850 to 1950s, early 1960, when most industrial development in the United States ceased and went overseas. We have radios, railroad, we even have a Wurlitzer pipe organ that's been restored, and we have antique toys and a number of other things, but our specialty is really antique radios. We do our own restoration on most of these sets. We have facilities here it's a replica of a 1930s radio shop where we actually do the restoration of our own radios.
The music you hear at the opening is John playing on the mighty Wurlitzer at the Carpenter Theater in Richmond. Nobody else will have that.
We're going to talk a little bit about the restoration of antique radios this morning. There's a lot of antique radios available if anybody would like to get into the hobby of restoring these things. eBay is a good place to find them, and you can very often find them in flea markets and antique stores. What I'd like to show you is a couple of the fine points about if you happen to get one of these radios and want to try to restore it, things that you should and shouldn't do right up front with it. This device that's up on the wall right here is a training device that was manufactured by RCA for the military during World War II to train the Signal Corps in how to maintain tube-type radios. It's basically a 5-tube superheterodyne radio that was popular in the late 1930s, and it's on a breadboard with jacks so that in the classroom environment you can actually demonstrate to students how to go about restoring or troubleshooting one of these radios. There's some basic parts here that follow through that are on almost every radio that you find in this era. There may be different tubes that you see at times, different types of tubes, but basically every radio has an RF amplifier, a converter, which is this stage right here, an IF amplifier, which is this stage, an audio first stage of amplification, and then a final audio output tube. This little section down here is the power supply. These tubes require high voltage to operate. Unlike transistors today, most tubes operated at something above 110 volts of DC power. So this is a power supply section that takes 110 volts coming out of a wall outlet and turns it into 300 volts approximately to run these tubes, and then of course 6 volts for the filaments.
Yeah, that's the high voltage is usually called B+.
Right, B+.
And then your filament voltage is what, A?
It's on a battery set. It would be called A. This is a tuning eye. This is a device that a lot of people have never seen. It's actually an early cathode ray tube that was used to measure the amount of automatic volume control voltage in a radio. These things generated a voltage depending on how strong the signal was. And by using that voltage, it was possible to control the volume on the radio so that you didn't have wild volume fluctuations on a set while you were listening to it if the station dropped off or if the ionosphere moved and caused your reception to go down.
Can we show them what that tuning eye does as you're tuning a station?
Yeah. Right now it's on this. Let me turn the volume up so we can hear. Right now we're tuned to a station, and if you look at the little bottom of the tuning eye right here, you'll see that little space in the green. It has a little notch at the bottom of the tube. That notch gets wider as the signal gets weaker, or if you get off of a station. If you're properly tuned in, that little notch is going to be as close together as can be allowed by the amount of signal that you have coming into the radio.
Yeah, sometimes called a cat's eye.
Cat's eye, yeah.
Yeah, and the radios that had these, they put it so it showed from the front of the radio.
Yeah, they usually pop through a hole in the radio, and some of them even went so far as to put an eyelid, a brass eyelid over the tube. If you get hold of a radio and you want to do restoration, there's a couple of things, or a few things that you want to be very careful of. For one thing, it's very easy if you have a short circuit anywhere in this this B plus chain we were talking about, this high voltage chain coming off of this power supply. You can very easily damage this tube right here, which is, you know, a rather rare tube. Now you can buy vacuum tubes. There are sources. A lot of them you can get them on eBay as secondhand tubes, but there's also companies that are making new tubes. And on my website, museumofyesterday.org, we have a link to several different companies that sell restoration parts for radios, dial glasses and a number of other things, tubes, capacitors, things that you can't find today in a normal radio or electrical supply house. What you want to be careful of on this is these capacitors right here. And this one, anytime you see this is called an electrolytic capacitor. Anytime you see one of those, age damages these capacitors. They're made up of wax paper and something tantamount to tin foil. And the wax paper dries out in time, and they can either short out or they can open up on you. If they open up, you get a hum when you plug the set in. If they short out, you can directly short this power supply out, damage the tube, and even damage the transformer.
And you'll more than likely see smoke.
Oh, you definitely see smoke.
You can tell electrolytics from other capacitors because they're polarized. You'll see a plus and minus on the pins.
That's correct. The other thing that you want to be careful of is this little capacitor right here. You see the plate, as it's called, which is the element that outputs the output element of a vacuum tube. It has high voltage on it going directly to the power supply. The signal from this tube, which is the audio, the sound that you want to hear, is also carried on that same element and wire. But what we want to do is we want to put that signal onto what's called the grid, or the control element of this tube right here, so that the tube can amplify that signal to the point where it can be operated, where it'll operate a loudspeaker. The thing that can fail in this case is this capacitor, because what this capacitor does is that it blocks that high voltage DC from going onto the grid of this tube while still allowing the audio signal to go through. If the capacitor shorts, you're going to dump 300 volts DC onto this element, which is going to cause this tube to go into full conduction, turn cherry red, and probably melt right in front of you.
Yeah, the control grid normally wants to see what, a volt or two?
Yeah, usually a negative voltage of about anywhere from 3 to 15 volts depending.
Yeah.
The other things that you want to be careful of in here, the IF transformers, these are interstage transformers that allow a certain frequency range to come through. The way a superheterodyne radio works is that the incoming radio signal, if it's 1,000 kc or kilohertz or whatever station you're listening to, is mixed against a local oscillator in the set that's running 455 kilohertz above whatever the incoming signal is. And that produces a single frequency signal that is going to be carrying all the information you're looking for. All of your audio information is going to be carried on that one frequency, so it then becomes possible to amplify very effectively that one frequency using these transformers. So if anything happens to these transformers, like you tighten the screws down too tight and short them out or anything, these are very hard to replace. You want to be very careful of anything that you could do to damage these. That's an important component that you're going to really have a problem if you need to replace it. And then finally, the last thing is the line cord. Of course, before I say the line cord, we want to be careful of any capacitor that's in the B plus chain. For example, in this radio we have a capacitor here that's designed to suppress any stray RF radio frequency that's coming off of this thing, which would cause the set to do what we call oscillating, which is making a kind of a blipping noise, feedback noise. You want to be sure that these capacitors are good, because being in the B plus chain, they could short out and damage the power supply just as well as the electrolytics could. The other thing that you want to be careful of is a line cord. Never plug in a radio with a line cord unless you check it first. The insulation on 30-year-old or 50-year-old or whatever line cords is going to always be suspect. And if you get a radio going back to the 1930s and it has the original line cord on it, you pretty well can guarantee that you need to change the line cord out. So always do that before you attempt to plug a radio into the power source, the wall.